Okay, so if you didn't watch the last video, please go back and do so because I talk about the common arguments and we're going to look at 6 of them. So we're going to pick up where we left off, and this particular problem is going to have us take the words and turn them into symbols, and then we're going to pick which argument matches it. So it says if you clean your room, then you go to the movies. So let's let P equal you clean your room. And let's let Q equal you go to the movies. So for line number 1, which is premises 1, it says if you clean your room, P, then you go to the movies, Q. So that's a conditional. So it's P1. And the second sentence, which is actually below the first sentence in this case, P2, says you went to the movies. So premises 2 is you went to the movies is Q. Now I have a line. That line is indicating that the premises are over, and then I have the word therefore, so I know I'm working on my conclusion. So my conclusion states that you cleaned your room. So that's P. All right, so I have if P then Q, Q, therefore P. Let's see which one matches up with that. Okay, if I look at the fallacy of the converse, I have this situation where I have premises 1 is if P then Q, then I have Q, therefore P. That says fallacy of the converse. Okay, if it's fallacy of the converse, that means the argument is invalid. It is not valid. Okay? Any of the fallacies of the converse, or the other one was the fallacy of the inverse, when that happens, you know it's invalid. Okay? And by the way, I did want to point out, remember that the converse is if Q, then P. See how premises 2 says if Q, therefore P. And inverse, remember, was negation P, then negation Q. So that's one way to tell which one's which. Okay, so let's go ahead and look at the next one. Given the set of premises, can you draw a valid conclusion? Okay, so this one's having us come up with a conclusion. So again, what I'm going to do is write things up in symbols, and then we're going to pick out what the conclusion should be. So if it's made with cheese, then it is healthy. So let's let P equal it is made with cheese. And let's let Q equal then it's healthy. So it is healthy. Okay, so line 1 says if it's made with cheese then it's healthy is if P then Q, the conditional. Quesadillas are made with cheese. So that is P. Now we're looking for the conclusion. So what I'm going to do is I'm going to look at my chart and I'm going to see if I find P1 equaling if P then Q and P2 is P. And when I do that, I see that matches up with direct reasoning. So the conclusion, by the way, is Q. All right, so conclusion Q. So I have to look for a statement that would match that up. So if it's Q, it is healthy, would be the conclusion. So if I look through this, I see for part C, therefore quesadillas are healthy. That is going to be my answer. So my answer is C. All right, let's look at the next bit. Draw a valid conclusion. We're going to write the premises symbolically and then match them to one of the valid common arguments. Use the conclusion from the arguments to write a valid conclusion. So we're doing the same thing, but we don't have a drop-down menu of A, B, C, D. So let's look at this. If fish climbs trees, then dogs drive golf carts. If dogs drive golf carts, then apples are vegetables. So I have 3 things going on here. So let's let P equal fish climb trees. And let's let Q equal dogs drive golf carts. And then we have another thing. I'm going to call that R. Apples are a vegetable. And I don't know why I put veggie table, but I'm going to fix that. Vegetable. Alright, guys. So let's look at premises 1. If fish climb trees, that's P. Then dogs drive golf carts, that's Q. Second sentence, which is the second premises. If dogs drive golf carts, that's Q. Then apples are a vegetable. So that is R. Now we need to find the conclusion. So we're going to look up at those valid arguments and figure out what matches up. So I need if P, then Q, if Q, then R. So if I go up here to that chart, I can see the one that matches up is transitive reasoning. Because it says if P, then Q, if Q, then R, therefore if P, then R. By the way, this is the only one out of the carbon arguments that we have on this page that has 2 conditionals in a row. And it's the only one that has 3 letters P, Q, and R. Okay? So our conclusion for this is therefore P, then R. So transitive reasoning, so we'll write that down. Okay, so the conclusion is if P, then R. So I need to write that up. So therefore, because we always lead off with the conclusion with that word, therefore, if P, fish climb trees, then, now I need R, apples are a vegetable. Okay, so that's what they're after. They're after you writing that out. Okay, draw a valid conclusion from the given premises. I study for my driver's test, or I do not pass the test. I did not study for my driver's test. Okay, so let's match these up. So I study for my driver's test is going to be P. And Q is I do not pass the test. Okay, so premises 1 is going to be I study for my driver's test, that is P, or I do not pass the test, which is Q. Premises 2 says I did not study for my driver's test. So that is negation P. I did not study. Therefore, now we got to match this up. So let's go look in the table to see if we have P or Q, negation P. By the way, the only one that has an or in it is a disjunctive syllogism. Okay, so I had P or Q, negation P, so the conclusion is Q. So the conclusion is Q. So I have to write down Q. I write down the word therefore, because I'm letting everybody know that's my conclusion. I did not pass the test, would be the conclusion. Okay. And we have another one. If a function is even, then the function graph is symmetrical about the y-axis. The graph of function f at x is not symmetrical about the y-axis. Okay, so I'm going to let p equal the function is even. And I'm letting q equal the graph is symmetrical about the y-axis. Okay, So let's look at the first line, which is premises 1. If a function is even, that is p, then its graph is symmetrical about the y-axis, that's q. Premises 2 says the graph of the function f of x is not symmetrical about the y-axis. So if it's not symmetrical, it's going to be negation q. Now we got to look at what the conclusion would be. Okay, so let's go back up to the chart again, and I'm looking for if p then q, negation q. Okay, I see that is contrapositive reasoning. So, whoops, contrapositive reasoning. Let's go back and do that. So the conclusion is negation p. Okay, and I'm just going to make sure really quick, but I'm pretty sure that's what it is because the contrapositive is if q then p. Sorry, it is not that. Negation q then negation p is what I meant to say. Okay, so I was right. It is negation p. And get back in there. Okay, so all I have to do now is write it up. So I'm going to write out the word therefore, because I'm telling everybody that's my conclusion. Negation p looks like the function is not even. Okay, so that would be my solution. By the way, this is the last part of 2.7. The next page shows extra credit if you should choose to do it. So thank you for watching, and go ahead and start your homework on this.